Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and let's get started on today's lesson. So today we're going to be doing Unit 2, Lesson 5. Our topic is transformations of parent functions, and your objective for today is I will graph and describe transformations of parent functions. So we've talked a little bit about parent functions in that we talked about y equals the absolute value of x, or f of x equals the absolute value of x, being a parent function. Well, there's lots of parent functions and lots of families of functions, and today we're going to dive into that just a little bit. So this first page is meant for us to help us graph the parent functions as we go along. Today's notes are a whole bunch of pages. Don't be too worried, it goes pretty quick, but it is a whole bunch of pages and a whole bunch of graphs. If you are doing this on notebook paper, because you don't have a printer at home and you can't print this out, you do need to sketch all of the graphs. So make sure your notes include a whole bunch of graphs. And please organize the information similarly to the way that I have it laid out here. So it's easy to follow and it's easy for me to check later on in class. All right, so the first thing we're going to do is we're going to graph each parent function, and then we're going to graph each transformation and write the new equation after we've graphed that transformation. So the first parent function we're starting with is f of x equals x squared. So I'm going to use the table for f of x equals x squared on the first page to help me find some values for x values that I can plug in, get a bunch of outputs, and then have a bunch of points to graph. So let's plug in -3 to +3. So if I square -3, I'm going to get 9. If I square -2, I get 4. If I square -1, I get 1. If I square 0, I get 0. If I square 1, I get 1. If I square 2, I get 4. And if I square 3, I get 9. So let's plot these points. -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So our parent function is at 0, 0, 1, 1, 2, 4, 3, 9. -1, 1, -2, 4, -3, 9. And you should see the shape of a parabola start to take place. Hopefully you graphed some of those in Algebra 1 last year, the year before that. So here we have the parent function of f of x equals x squared. All of these things are going to be a transformation of this parent function. So let's translate this function up too. If you look at your cheat sheet from your absolute value equations from Unit 2, Lesson 4, so grab your cheat sheet from Unit 2, Lesson 4, you will know that if we shift a function up 2, that's the same thing as taking the function and adding 2 to the whole thing. Well, the similar thing happens here. We're going to take this whole function, f of x, I should have said like plus a number, f of x equals x squared, and we're going to add 2 to it. So f of x equals x squared plus 2. Then we're just going to take each of these points and we're literally going to shift them up 2. So this point, if I shift it up 2, is going to end up at 0, 2. If I take the point 1, 1 and shift it up 2, I'm going to end up at 1, 3. Yeah. If I take the point 2, 4 and I shift it up 2, I'm going to end up at 2, 6. 3, 9 will be at 3, 11. And then same for the other points as well. And we've taken that parent function and we've shifted it up too. That line, that curve turned out a little nasty, huh? All right. Now let's do another transformation. Now let's translate it down 2 units. So translating down 2 units, what does that look like in the equation? we would have f of x is equal to x squared. So if you look at your cheat sheet for your transformations of absolute value functions, if I shift down 2, that would be the same as subtracting h from the entire function. So I subtract 2 from my equation, the entire equation. All right, so now we're going to take our parent function and we're going to shift it down 2. So if I take this point and shift it down 2, it's going to move down to 0, -2. If I take the point 1, 1 and shift it down 2, I'm going to end up at 1, -1. The point 2, 4 is going to go down 2 to 2, 2. And then 3, 9 will shift down 2 to 3, 7. And then we're going to do the same with the other side. And there we go. All right, so let's see what we have so far. So far we've taken this parent function, this purple parent function. We shifted it up 2. Then we shifted it down 2. And now we are going to reflect it over the x-axis. So if I reflect the function, so if you look at your cheat sheet, you should have something like y equals the negative times the absolute value of x. Remember that negative reflects that parent function over the x-axis. So f of x is equal to x squared. If I want to reflect it over the x-axis, I just multiply the whole function by a negative. So let's go ahead and graph what that's going to look like. So the first point is at 0, 0. If I reflect it over the x-axis, well, this is the x-axis right here. Since that point is on the x-axis, we just leave it there. Reflecting it over the x-axis keeps it in the same spot. The point 1, 1 gets reflected over 1. The point -1, 1 gets reflected. The point 2, 4 would get reflected 1, 2, 3, 4. So 1, 2, 3, 4. And the point -2, 4 would get reflected 1, 2, 3, 4. So 1, 2, 3, 4. And then 3, 9 would become 3, -9. -3, 9 would become -3, -9. And there we go. We've reflected that thing over the x-axis. And all I did was flip that function upside down. All right, so now we're ready for the next transformation. We're going to translate our parent function to the right too. So we're going to take this thing and shift it to the right. Well, if you look at your cheat sheet, you're going to notice that to shift things right or to translate right, we have to subtract h directly from x. So to translate y equals or f of x equals x squared to the right, we're going to subtract 2 directly from x. So in the thing that's being squared, we're going to subtract 2. So f of x is equal to x minus 2 squared. So what we're going to do is we're going to take our parent function. Remember, our parent function was at 0, 0, 1, 1, 2, 4, 3, 9, and then the opposite side of that as well. And we're going to shift all these points 2 to the right. So this point is going to go here. This point moves here. This point moves here. This point moves here. And so on and so forth. And we've shifted f of x equals x squared to the 2 right. All right, now what about translating left? So why don't you try this one on your own? What would the equation become if we're translating 2 to the left? And then what will the graph look like? Make sure that you use your cheat sheet to help you figure out what the new equation will look like. And you can even use this equation as a hint. If subtracting 2 directly from x before you square x shifted us to the right 2, then how are we going to shift to the left 2? Go ahead and pause this video and give it a shot. And when you're done, press play and check and see if you're right. All right, so the function that you should have written is f of x equals x plus 2 squared. And then I just shifted all of the points from our parent function to the left 2. My graph looks like this. The vertex of this parabola is now at -2, 0. And then you can see all the other points just shifted to the left 2 as well. All right, now let's talk about doing a horizontal stretch by a factor of 1/2. So a horizontal stretch by a factor of 1/2. So what this means is y is equal to, f of x is equal to x squared. So remember, on our cheat sheet, if we want to stretch something horizontally, we multiply it by a. We multiply it by that number a. So we're just going to multiply x squared by 1/2. So if we were to plug 0 into this for x, so 0 squared is 0, 0 times 1/2 is 0, so we'd still get 0, 0. If we plug 1 in though, well, 1 squared is 1, and 1 times 1/2 is 1/2, we would get 1/2. So we get the point 1 and a half. We'd also get a half if we plugged in -1. So now let's plug in 2. So f of 2 is equal to 1/2 times 2 squared. Well, 2 squared is 4, and 4 times a half is 2. So we get 2, 2. And then if we plug in, let's actually plug in 4 instead of 3. So we'll get a whole number. Let's plug in 4. F of 4 is equal to 1/2 times 4 squared. Well, 4 squared is 16. Half of 16 is 8. So we get 4, 8. And we would get the same values if we plugged in -2 and -4. And we see that our graph stretches just a little bit wider than our parent function. All right. Now let's do a horizontal shrink by a factor of 2. So on your cheat sheet, you should recall that f of x is equal to a times the absolute value of x. If we multiply the parent function by a by a number that's bigger than 1, we're going to get that horizontal shrink. So f of x is equal to, our parent function is going to become 2 times x squared. So let's go ahead. If we plug in 0 again, 0 squared is 0 times 2 is still 0. So we still get 0, 0 for our vertex. The graph doesn't shift up, down, left, or right. Let's plug in 1. Well, 1 squared would be 1. Here, I'll write this out. 1 squared would be 1 times 2 is 2. So we get 1, 2. Let's plug in 2. Well, 2 squared is 4. 4 times 2 is 8. So 2, 8. And then we get the same thing if we plug in -1 and -2. And so we see that this graph got skinnier. We've got that horizontal shrink. All right, so there we go. We've got all of these awesome transformations for the parent function, y equals x squared, or f of x equals x squared. We shifted it up, we shifted it down, we reflected it over the x-axis, we shifted it right, we shifted it left, we stretched it, and we shrunk it horizontally. All right, let's move on to the next parent function. So the next parent function is f of x equals x. Okay, this is a linear function. So all of these graphs are going to be straight lines that are going to get shifted around. So let's use our table of values on the first page to help us get started with graphing this thing. So f of x equals x. Here's our table of values. I'm going to plug in -3, all the integers from -3 to +3. Well, if I plug in -3, I'm going to get f of -3 equals -3. If I plug in -2, I'm going to get -2. If I plug in -1, I get -1. If I plug in 0, I get 0. If I plug in 2, I get 2. If I plug in 3, I get 3. If I plug in 1, I get 1. So we have the points -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, and 3, 3. So let's graph our parent function. So we got -3, -3, -2, -2, -1, 0, 1, 1, 2, 2, 3, 3. And I see that I have this straight line happening. Hey, it looks like I go up 1 over 1. I have a slope of 1. So if I wanted to find more points, I would still go up 1 over 1. We've graphed this line before. All right. Why was that line terrible? All right, so now let's translate this thing up 2. So how do I translate something up 2? I add 2 to the entire function. So I'm going to have f of x is equal to x plus 2. So shifting it up 2, we're going to go from 0, 0. This point that was 0, 0 is going to go up 2. So now we're at 2. Well, hey, my slope is still 1. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. These straight lines are super easy to graph, huh? All right, there we go. Ooh, don't forget to label your x and y axes. All right, what about translating down 2? Why don't you go ahead and write this function and graph it? Remember to use your cheat sheet. So f of x equals x translated down 2. What does that equation become? Go for it. All right, so your equation should be f of x equals x minus 2. You should have a y-intercept at -2 and then up 1 over 1 for your slope. Graph a bunch of points, draw the line through them. All right, moving on to reflecting over the x-axis. So for this one, you're going to be writing the equation. What does f of x equal x become if you reflect it over the x-axis, and then go ahead and graph that line as well. Go ahead and give it a shot on your own. Press pause and then press play when you're ready to check your work. So the equation you should have is f of x equals -x. So these blue points that I plotted are the original points from the parent function. If I reflect them over the x-axis, I'm going to have, well, 0, 0 stays the same. 1, 1 reflected over the x-axis becomes 1, -1. This point becomes this point. This point becomes this point. Do you see how they're still 3 apart above the x-axis and then 3 below the x-axis? This one is 4 above, this one's 4 below. This is 5 above, this is 5 below. So I know that I've reflected my points correctly. Well, if you see my new line, this pink or red line, has a negative slope of -1 and a y-intercept of 0, 0. So this is the parent function, f of x equals x, reflected over the x-axis. All right, now let's try translating right 2 units. So for this one, I'm going to go ahead and do this one with you because you might feel like it's a little tricky. Well, to translate right, I know I subtract a number directly from x. I would do like x minus 2. Well, because our parent function was just x by itself, there's nothing to really like multiply, or there's nothing to do to this x minus 2. So it's really the same as f of x equals x minus 2. So remember, for the parent function, our first point was like 0, 0. If we shift that point to the right 2, we're going to end up here. Well, our slope is still 1. So if I go up 1 over 1, up 1 over 1, etc., you can see that my y-intercept is now, it went from 0, 0, and it's now at -2, or 0, -2. Well, translating f of x equals x to the right 2 is the same thing as actually shifting it down 2. This is kind of a funny function like that. It just happens because it's linear. Those two transformations are really the same thing. All right, why don't you go ahead and try translating it left 2. Make sure you write your equation and graph it. So go ahead and check your work with mine. My equation is f of x equals x plus 2. I could rewrite this as this. There's technically like a 1 out in front of these parentheses that you would distribute, but 1 times x is x and 1 times 2 is 2. So it's the same thing. So then 0, 0 got shifted to the left 2 at -2, 0. I went up 1 over 1, up 1 over 1. And this function is the exact same function as shifting it up 2. So shifting a linear function to the left 2 is the same thing as shifting it up 2. Interesting. All right, then stretch it horizontally by a factor of 1/2. F of x is equal to, you just multiply the parent function by 1/2. So x times 1/2 or 1/2 x. Well, my y-intercept would still be at 0, 0, but now my slope has changed to 1/2. So I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, etc. No, that's a terrible line, sorry. There we go. All right, why don't you go ahead and do the horizontal shrink by a factor of 2. Write the new function and graph it. Press pause and then press play when you're ready to check your work. So if I do a horizontal shrink by a factor of 2, my equation becomes f of x equals 2x. When I graph it, my y-intercept is still at 0, 0. My slope becomes 2. So I went up 2 over 1, up 2 over 1, etc. All right, so now I want you to try doing one by yourself. So here's the parent function. F of x is equal to the absolute value of x. You are going to go ahead and write all of the equations. You're going to graph them all on your own. I'll help you get started on your table of values for this parent function. F of x equals the absolute value of x. So I'm going to go back to my first page. F of x equals the absolute value of x. If I plug in -3, when I take the absolute value of -3, I get 3. The absolute value of -2 is 2. The absolute value of -1 is 1. Then 0, 1, 2, 3. So go ahead and graph all of those points. Do all the transformations that you're given for this parent function in particular. And then go ahead and move on and do the rest. The only one that I want to warn you about before you get too far in this is when you get to f of x equals the square root of x. We can't take the square root of a negative number and get a real number. So when you plug in x values for this parent function in particular, I would just plug in 0, 1, you could do 2, 4, maybe even do 6, and I would do 9. 0, 1, 4, and 9 are going to get you perfect square roots. The other two numbers, 2 and 6, you might want to plug into a calculator to find the square root of those. All right, so go ahead and get to work. You are in breakout rooms for the rest of the period. We're doing things just a little bit differently today. And so if you need help, you get stuck, just hit that ask for help button at the bottom of your screen and I'll jump into your breakout room and answer your questions. Go ahead and finish this up. So you're going to do the rest of the parent functions, you're going to graph them, and you're going to write the equations of the new translated functions. Let me know if you need anything. I'll see you back in class. Have a good day.